Okay, Assalamualaikum and hello. So we continue with study with chapter 4, which is input and output. So if you recall back your flowchart here, maybe you start. Okay. So and then you goes to something like this. Okay. Parallelogram, everything is called. So this one is basically input or output. Okay, if you have any input or any output, you have to use this one, and then you have the equation, the process, and then if you have the output, you will use this one. So I think many of you already see that there is some coding called input and display. So that is basically input and output. Okay, so input, you can just use the function called input, input, and the output is disp. Okay, beside this, okay, there is also called print. Okay, print function. So this one will be discussed in the in this chapter 6. Okay, input and output. Okay, so we continue. So the objective is to prompt user to input an M file program. So and then display, this one actually you already learned about it. Okay, but this one is new, fprintf and sprintf. And then you can learn about load and save. Okay, this one is useful if you want to save the data in MATLAB format. So this one is safe for the Excel format. And then you also have, you will learn some debugging. Okay, so all of these you will learn today. So just recap. Okay, so you learn about variable operation. Okay, so basically you can now create a program. So after you create a program, of course in a program or algorithm you need to have an input. Okay, you put an input what you want for that program algorithm, and then the output will process the algorithm. So type of input and output data. Okay, so prompt data is created or displayed in the command window. Okay, so what is this mean is that the data is basically displayed in the command window in the MATLAB here. Okay, so we can create a prompt data when running the script or function. Okay, but the problem is the data is temporary. If you close the MATLAB, the display will be gone. Okay, the data will be gone. Okay, okay. Also, you can also clear it with clear. I already show you how to do this. Okay. So useful as a quick test input and output data. So if you want to calculate something quickly, it is good to use prompt data because it's just quick. Okay, and another thing is the import and export data. So this is usually for the large algorithm program, so you can store it in the MATLAB format called .mat or data or text or Excel. This one is Excel or MP4, but for this class you only focus on the mat, this one. Okay, mat and Excel. Okay, and this data is permanent. If you close your computer, turn off, okay, it's still there. So this is two types of data available for the MATLAB. Okay, prompt input and output data. So first one is the prompt input, request and input. This one I think you already learned about this, okay, before actually, because when you want to learn the previous chapter, you actually have to learn about this. So basically input is you just want to store the data where equals to input. Okay, this is the code and then your message. So just use this one. This one also can be used. Okay, I suggest you all can just use this one. Okay, so display the text in the message and wait for the user to input and press return key. So return key is basically enter. Okay, so you can enter any type of variable, okay, random, okay, or when s is used for second input to the function. Okay, maybe we look at the example for more understanding. You can see here, you have input height, okay, and input width, okay, and then you can calculate the area. So 0.5 multiplied by height multiplied by width, okay, you get the area. Okay, so this is, I think, the area of triangle. Okay, if not mistaken, area of the triangle. So you can see here, this is the message here. This is the message. Okay, you can put the message here, and don't forget about the open bracket and close bracket here, and you have to enter it manually here. Okay, let me show you in the MATLAB. Okay, for this case, I suggest you use a script, the new script. Okay, if you can also run here, but it will become more complicated, so I suggest you run it in the script. Okay, so I suggest also you put the clear CLC close all. In the exam or test, don't need to write this, but in your real program you have to write this. Okay, so when you run this, it will run the first item, okay, first command, okay, and it stop. Okay, it will not run the second command until you press enter. So maybe I press 2 and then press enter, and of course it will run the command in the line 4 here. Okay, the second command. Okay, I click here, maybe 6. So after I enter, okay, height and width will be created and will be calculated using this one. So it will generate the data, okay, the variable in the workspace. You can see here, height is 2, width is 4, and automatically calculate the area. So that is how input works. Okay, don't forget about this one, and I suggest you put space, okay, because of this. Okay, that's it for input, which is very direct to the point. Okay, and next one is output. So for output, you have, for this class, you have 3. Okay, so I think there are 4 methods without semicolon. Of course, remember that I said if you want to see the answer, you just remove the semicolon at the end of the code. So I give you example here. So I put semicolon here. So it will not show the answer, but if I remove this, I will see the area. Okay, so area is equals to 4. Okay, it will be something like this. Another way is use display function. Okay, so display only the value of the variable without the variable name. Next is the fprintf function. Okay, this one is you can format the string. Okay, so what do you mean by format the string? Okay, I will show you later. Okay, so if I use display, okay, so if I use display, maybe if you have a number here, okay, 0.1, 2, 3, okay, for example, it will show 0.1, 2, 3, okay, or text, and of course you have to change it to string. Okay, that is for display. But if you use fprintf, you can manipulate this number. For example, you don't want 3 decimal point, you only want 2, so you can print it as 0.12. Okay, that is the advantage of fprintf. So next is the sprintf. Hold the value of variable without formatting string, return the value of the variable. Okay, and sprintf doesn't print anything on the command window. Okay, for this one maybe later I will show you. This one is a little bit tricky to explain. Okay, we start with the display function. I think already you already know because it's already been used in the previous chapter. You can see here, x is equals to 1, 2, 3. Okay, so if you don't put semicolon or you just write x, you will get the answer. Or you can just display x, okay, you will get the answer. Okay, So that is what I said before, without semicolon, or you can use display function. Either you can get the result. Okay, I think that's it. The display function is direct to the point. Okay, but the fprintf function is a little more tricky. Okay, but it's offer more formatted output display. Okay, so you can control the output like I said before, and you can combine text and number easily. For display function, usually you have to put a open bracket, your text, close bracket, and then you have to convert number to string. Okay, which is very difficult. Not difficult, but it is tedious. For me, it's tedious because you have to write the num to string, because you have to convert the number to the string, and then you have to. It's quite difficult. Maybe you can recall back the previous chapter. Okay, but for fprintf is direct to the point. Okay, so how to use fprintf? Just write fprintf. Okay, so you can control the combination of text and number easily. You can control how many digits to be displayed in the position. Okay, so string is display without format. Okay, I think this one I suggest you just look at the example. It is much more easy to understand. Okay, so how to use the fprintf? So this is the formatting on how to use fprintf. Okay, for this class, if not mistaken, you will not use all of this, but you have to know this one. Okay, the field width. Okay, the precision. Okay, and the conversion. Okay, this one, conversion. So you have to know if you want to use integer. Integer is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so you have to use %d or %i. Okay, easy to remember. I in integer, d decimal, I think. Okay, and this is sign. Okay, sign value. But if it's not sign, means that it's always positive. Okay, it will be u, unsigned u. And you have floating f. Okay, if you have string, okay, string is basically a, b, c, d. Okay, %s. Okay, exponential is 1 multiplied by power 10 power of 3, -3, -4, something like that. This is the what you call the scientific way to show the result. Okay, floating, or sometimes you can also use %g. G, I think, is called general. Okay, it is much more easy to use. Basically, it will detect the result itself. Okay, but you have to know this. Okay, and then you have to know the precision and field width. Other than that, let us check after this. If not mistaken, it will not cover in your courses. Okay, let's have a look at example 6.3. You can see here cow is equals to 5, which is some kind of input. Okay, so and you print this, there is a %1.2 f cow in the pasture. Okay, so what it means by %1.2 f cow? Okay, the first thing you need to know, you have to put this. Okay, you have to write the message, any message you want. Okay, you need to put open bracket and close bracket. Of course, comma, and then you have to put the variable. Okay, the variable that you want to put in the text, and of course you want to put it here. Okay, you want to put it here. Okay, the cow value. So f is the floating number. Okay, floating number usually also general number, and 1 is basically it said that you need to place an extra. Okay, let me just read this. The string which has first argument fprintf function contain the placeholder. Okay, this one is called placeholder, the percentage where the value of variable cows will be inserted. Okay, like I said before, this value of cow, the first one will goes into here. It is just a placeholder. Okay, so the percentage of the placeholder. Okay, And the place also contain formatting information. So for example, the %1.2f tells the MATLAB to display the value of cow as a 1.2 fixed point in format. Okay, 1 digit before the decimal point and 2 digit after the decimal point. Okay, so decimal point, okay, before you have 2 digit, after you have 1 digit. Okay, so basically it's just a placeholder. Okay, and the format is of course float number. Okay, float is basically double. Okay, so basically just a number. So let us test this for easy understanding. Okay, now I think it is much more easy to understand. You can see here, if I run this, there are 5.00 cow. So means that you have 2 decimal point here, 0.00, even though the cow is only 5. Okay, and you will write all the text here. Okay, and if you want to add a space here, you just press back slash, okay, the one at the top of the enter, and new line. So run it, it will create a new line. Okay, this is just a tips for you. I think it will be in the slide later. So you can see here, it will takes the first value. Okay, so example cat is equals to 2. Okay, so how to I will write this. Okay, so basically copy this, okay, and place the placeholder. Okay, this one is called placeholder. Okay, and then the variable for the second placeholder you put here, you have to put after the cow, because for the first placeholder it is reserved for cow. This one, the first placeholder, and the second one is cat. So you can see here, if I run this, it will, there is a 5 cows and 2 cats in the pasture. Okay, something like that. Okay, how about if I want to adjust only 0, no decimal point? So if I run this, there is no decimal point. Okay, how about I put 500? Okay, it will create 500. Okay, how about if I change this to 3? So if I run this, okay, it's still the same, because 500 takes 3 places. Okay, but how about 6? Okay, so it will create 6 spaces, 1, 2, 3, 4, 5, 6. Okay, this one space is this space. Okay, that is means by space. Okay, 6 and 0. Okay, why this is useful? Usually if you do something like this, okay, cow is equals to something like this, and you put a space here, slash n. Okay, and then you write cat. Okay, cat. Okay, so if you want the space to be the same, you just put 6, same and same. Okay, what happened is that when you do this, okay, if you run this, okay, the space is the same. Okay, this one I forget the space. Okay, you can see here the location will be the same. Okay, that is the advantage of using this. Okay, so it will be parallel. Okay, if you want to adjust it to 7, this one also 7, it will give the spaces. Okay, have a break. Okay, you can open the e-learning. Okay, I will put the attendance in the e-learning at the top near the WebEx link. Okay, you can slide in your attendance. Okay, so we continue. Okay, sorry, my PC is acting up. Okay. Okay, so we continue with the next part. Okay, so you can see here the fprintf with multiple value. So I hope you already understand the placeholder concept. So basically, this is the first placeholder, this is the second placeholder. Okay, so if you look here, this one, okay, you can see this is the percent 2.2. I already know what is the function of 2.2. Okay, this is just a placeholder before and after the dot. F is the format of floating. How about M? So M is just a meter, the unit. So if you write something like the FM, okay, you can write anything after the F. Okay, so it's only consider this as the format. Okay, this one. Okay, the conversion. Okay, so basically it's just a M. So this one is MM. Okay, so that is the first thing you have to understand. And then you can see here the data is 1, 2, 3, 4. So you have 4 data, but you have only 2 placeholder, which is 1 and 2. So what happens if you have 2 placeholder but 4 value in the variable? So what it will do is just, okay, let me clear this first. Okay, so what it means is that it will print the first column. Okay, so it will print this one first, and then this is the second one, this is the third, and this is the fourth with the same code. Okay, that is what happened. Okay, so let us look. Okay, and of course this is a new line. Okay, new line, backslash n. Why this is important? Because we want to look at the back. Okay, so wait. Okay, if you copy this code, okay, so this one, of course, you have to change it back. Okay, this one, just write it back. It will become okay. So if I run this, you can see here you have 20. Okay, this is 20. This is 2000. This is the second one. Remember the index. Okay, so if you have data, it will calculate this one. Complete the first row first from the left. Complete the first column left first. Okay, from top to bottom from the left. Okay, and then to the next row from top to bottom. Next column to the top to the bottom. So it will print according to that, because you have 4 data and 2 placeholder. It will print this 2 times. Okay, so make sure you understand this concept. Okay, now a special character. Okay, sorry, my PC is acting up. Okay, so when you use fprintf, of course, inside there you cannot use quotation mark. Okay, the open bracket and close this one. This is quotation mark. Single quotation mark. Double quotation mark is okay. Okay, why? You can see here, this is the coding itself. If you do that, the program becomes confused. Okay, the fprintf become confused. Okay, so this is quotation mark. Okay, percentage, of course, this one you cannot, because this is for chapter, reserved for the MATLAB. Backslash also has an other function. Backslash n is the new line. Okay, backslash a is the alarm. If you want to create an alarm, we just put backslash a. Okay, this one also cannot. Okay, this one also cannot. Okay, so when you come to when you use this, make sure you be careful, especially if you use backslash. Okay, backslash means that it is reserved for MATLAB special program. Okay, how about Greek letter? Okay, so if you want to put a Greek letter, okay, you can just put this one. Okay, this coding %x. So you will use a Unicode. Okay, you can Google it. Okay, what is Unicode? Okay, and usually in the test or exam they will give it, because you cannot memorize all the Unicode. Okay, so for example, W, right, omega. So omega, if it's hard to write, right? So, you want to write omega in the MATLAB, you can just use %\x 3co. 3co is the code for this one. Okay, so let's test this. Okay, so I have transferred this into the MATLAB. So I think you can be a little bit confused because of this. Okay, so fprintf, this one is basically the combination of multiple point. I think this one is quite confusing, so I just remove this. Okay, if you don't want this to be confused, okay, you just remove this, and the square bracket. Okay, you can just put this. Okay, automatically it will create an omega. You don't need to put this one. Okay, this one is also remove the this one. Okay, so just put this. Okay, so you can see here. Oh, I forget to remove this one. Okay, so if you run this, you will still get the answer. Okay. Okay, I think there's something wrong with this one. Oh, okay, so this one I forget to create a new this line, forget to create a new line. So backslash and okay, so it will become something like this. Okay, so you can see here, this is omega. Okay, 3cx \x. Okay, and then the Unicode for omega, this one is 3c9. Okay, and this one sine omega 3c9. Maybe you can have another space for balance it. Okay, okay, so this line is just the first one, but for the second one, okay, you can see here wp and s. Okay, so what it means that you have two variables. Of course, yeah, if you want to avoid the confusion again, I just remove this. Okay, just use comma. Okay, so it will produce the same result. Okay, so this is the first placeholder, this is second placeholder. Okay, so of course, this is the first placeholder is reserved. This is second placeholder for the reserve. All use floating. And the first one has 10 space, so basically there's 10, 1, 2, 3, 4 until 10. Okay, so 3 decimal point, this one is only 1. Okay, and this is pi. 3co is 5. Don't need to memorize because this one usually will be given. You don't need to remember the Unicode. Okay, so basically it will print w. Okay, w you can see here, this is w. Okay, this is w divided by pi. So basically it will change from the radian back to this one. Okay, you just divide by pi and put the pi, this one. Okay, and s is the sine. So this one is in radian. Remember, if you want to use sine in MATLAB, it will be in radian. In degree, you have to use different code than the sine. Okay, so because you have 4 data, okay, for s. Okay, for s and okay, for this case, okay, unfortunately you have to make a bracket. Okay, so remember that I said, okay, the data will read from first one first, okay, and then second one. So let's have a look here. Okay, remember about the placeholder of you cannot remove this. Okay, so basically you can see here, it will create a s first. Okay, it will put a s first, and then in the new line it will create w. So if you want to see it, the new one, okay, I put it AA. So wp, you copy this first. Okay, this one is AA, and then this one is the S. So what happened is that automatically, because of the square bracket, okay, the first line and the second line, something like this, so it will create, okay, why it cannot be copied, okay. Oh, wait, so it will create something like this. And remember the placeholder before. So basically, if we read the first column, this one first, and then the second column, and the third column, and the fourth column. That's why you cannot remove this. Okay, this one because of the placeholder. Okay, because the fprintf will read this one first, this one, and this one. Okay, so make sure you understand how the system works. Okay, so it will print W first. Okay, you have W, and then you have S. Okay, this one is don't have any value, but should be. Okay, this is S, this is W. And if you do something like this, basically you write the W divided by pi, okay, and the new line will S. So it will become something like this. But this one changed to 0, 0.5, 1, and 5. So it's a little bit tricky here, okay, because of this one. So make sure you try to understand this. Okay, so this one you have to be a little bit creative because how the fprintf reads the data. Okay, so this is the Greek letter. Okay, now this is the Unicode. Okay, of course you cannot remember this all, no worry, it will be given in the final exam. Okay, so if you want to use degree, okay, alpha, beta, okay, eta, which is the common one, lambda, angle, okay, all of this is available, but you need to know the Unicode. Okay, remember slash backslash and X, and then insert the Unicode. Okay, so next is the sprintf. So you can take a break. Okay, I think that one is a little bit tricky. Okay, so we will continue next with the sprintf. Takes 5-minute break. So we continue with the next part, which is sprintf. So basically it's the same. Okay, sprintf and fprintf is the same. But the advantage of sprintf is that it can return the output of string as a variable. So before this fprintf is mostly more towards the 1, 2, 3, 4, 5. But for sprintf is more towards the A, B, C, D, E. Okay, so that is meant by this sentence. So more towards string. Okay, for example, create a sequence file name when there is a number of files to be created at once. Dynamic range. Okay, dynamic cell range, referencing when importing, exporting data from the spreadsheet or graph annotation. Okay, so let us look. Okay, so this is an example. F is equals to fprintf sum output is 4.2 f. This is a new line. So this, okay, space is reserved for the pi multiplied by 1000. So you can see here, pi multiplied by 1000 is 24. Okay, so sprintf, okay, so basically it cannot print this component. Okay, it's just display the size of the string. Okay, so this is the limitation. Okay, so for the second one, if you use sprintf, sum output is this one, pi multiplied by 1000. Okay, you get the sentence and as well as the answer. So fprintf has limitation, so you can use the sprintf. So let us look. Okay, here is the MATLAB. So for this case, I use a script instead of the command window. So I just run this. So you can see here. Okay, maybe So f is just 24. Okay, s is become this. Okay, if you can see here, this one become character, this one is become double. Okay, if 1000, no problem. Okay, so if I remove this, okay, let me remove this. Okay, so basically it will become something like this. Okay, I think no need to worry about this. So basically fprintf is just saved as a double character, floating number, but s is just a character string. Okay, so for this case, no need to worry. Okay, so this is another example you can try. Okay, so you can just copy this. Okay, this is just basically combination of input, display, and s, print s. Okay, so maybe you can try this, copy this. So for this case, you have input and output. I suggest you use script. You cannot run in here, and of course there will be error here. This one just okay, punctuation if I'm not mistaken. Okay, just replace it. Okay, near the enter button. Okay, so this one also has problem. Okay, if you run this, what starting value degree do you like? 0. But final degree we like 180. So increment 20. So it will produce this one. So what you can see here, this one is just print, okay, because there is no value, just use display. But for this case, okay, so you can see here fprintf, you have degree, okay, degree, okay, and read. So basically this is just a title, and you can see here the /x36. oh, this one is for pi. Okay, so basically just a title, and now this is the main part. So you can see here, this is the first placeholder. Okay, this is the degree symbol. Okay, and this is the second placeholder and new line. This is also new line. Okay, okay, display no need to the new line because it's automatically create a new line. Okay, so table. So table here you can see it will make a square bracket, this one. So basically remember that I said fprintf will read from the first column, then the second column, and the third column. So you can see here in degree, this one is degree, so this is the first row, okay, and the radians here is the second row. Okay, what is it do is basically just convert this. Okay, place this in the first row, place this in the second row. So remember semicolon in the square bracket from previous chapter, you can see here. Okay, this is chapter variable, chapter 2. Okay, so basically it will create, okay, table here. Basically just copy first row and then second row, because the fprintf will read first row and then second row and then third row and then fourth row. Okay, so that's why you have to sort the table like this, and then you just insert the table here. It will automatically print everything up. Okay, now we move on to the next part of the slide, okay, which is import and export. So previously it's just a common window, this one. Basically the data is not permanent, it's just a temporary display. So like I showed before, okay, so prompt data, and next is the import and export data. So this one is more permanent. When you turn off your PC, it's still there. So you have import and export. I think most of you know what is import, what is export. So import is just from the disk to the MATLAB, and export from MATLAB to the disk. Okay, so you can save as two format, either text format in binary format. Okay, and MATLAB use function load and save to import the data. Remember that I said that .mat. So MATLAB has its own data, okay, has its own format for saving data. So you can use save and load. Okay, so how to use it? Okay, I will show you later. Okay, sorry, next slide. So you can see here, for example, here you have A, you have B. Okay, how to save the data? So just save and then write the name of the data. Okay, and then data you can also save in another format. So you can see here for data1 .mat is saved as binary. Okay, this is the default. If you don't put the format here, it will automatically save as binary. Okay, so the file contain all the variable from the workspace. So basically, when you don't write anything, you just write the data1. This one is name. You can put any name, and but make sure you mention .mat. Okay, so basically it will just save all the parameter in the workspace. Okay, so that is save what the name of the file and then .mat, and it will save in this one, your directory. Okay, and for second one, this one save as data.dat. Okay, usually we don't use that. We usually use .mat. And this one you can save it as a ASCII. This one is just a format for the saving file. Okay, and this one is binary file. Okay, so this one also can. Okay, binary file. You use mat, it will save as binary file. And for this case, you save the file as this format, and you only save A. B will not be saved. Okay, so basically, if you want to save the data, save first, write save, and then the data name together with the extension, and then space the data that you want to save. If not, write this, it will save everything in the workspace, and then this is the format. Same here, if you want to save only A, you just put A. Okay, so let us look here. Copy this file. So make sure you remove this beginning, because this one run in the common window. So when you run this, okay, unfortunately this one also out of format, so you just highlight it negative. Okay, replace it again. Okay, some of the data from the slideshow cannot be submitted in the MATLAB, so you just rewrite it again. So if you run this, okay, you can see here it will create 4 data. So you can see here, okay, sorry, this one is the mat data. So basically this is the standard MATLAB format, and also you can save as DAT. This one is more towards window. Okay, so data2 in the format of ASCII, this one in the format of binary, and this one does only save A. So if I clear this, okay, if I double click this, okay, basically it will load again the data. And for this case, okay, you can import this. So I suggest you don't use this one because it's not very good. Okay, you just import it. Okay, better to use that. Okay, data, but depend on the question. If the question asks to save in the form of data, okay, DAT, and the format, make sure you know how to do it. So for this case, let me clear this. Maybe I just want to save B. Okay, so if I run this, okay, so I clear this up. Okay, if I press the data one, you can see here only B is saved. Okay, make sure you know how to use both. So you already learned about how to save data. How about to load the data? So you can see here there are 2 data. Okay, so I think this one already show you before. Okay, maybe I just run it again. So I put a breakpoint. This is called a breakpoint. It will stop running until here. So you can see here when I run this, okay, basically it save this 2 data, or maybe I delete this first. Okay, so I run again. So you can see here it will save data 1 and data 3. Okay, and then I clear the data. So basically your workspace is empty, and then load data mat. So automatically it will import the data. That's it. Save and load. Okay. Okay, one thing you should know also, binary file, okay, these two, okay, save both variable and name, okay, variable name and its value. So you can see here you have A and B, okay. So thus loading the binary into the MATLAB will import the variable and name, okay. So the result will be the same because this is binary format. This is the advantage of binary format because you also save the name A and B, okay. But for the ASCII file, okay, it's only save the variable, okay. For example, here you save A 1 2 3 4 5 and B is 2 4 6 8. So if you load clear it up, you load it again, you can see here, okay, the name of the data is only data 2, okay, because you save it as data, it should be data 2, okay, and there is no A, there is no B. All of these will be converted into one location. So maybe if you want to remove all the data, you can use ASCII, okay. But if you want the name, also better to use binary, okay. And basically this is the default format to save the file, okay. Okay, for this case, this is just an example based on the input and save and load function. So in the example, we are going to create a function that convert a string Greek letter name alpha beta to a fixed hexagon value. Okay, this hex value will be useful when you want to display the Greek letter using fprintf and sprintf. So basically, you save the Greek letter for alpha and beta, save it in the mat file, for example, and then load it again and print it. Okay, because remember, it's hard to memorize all this. Okay, so basically the code is just an example on how to save the Greek here, the table before I show you, into the mat file. Okay, so to do this, create a mat file. Okay, this I already mentioned before. Okay, so this one, create a conversion according to the conversion file. So in this example, cell array data type will be used, not previously covered, basically. Okay, so basically this one is, maybe you should look at the coding. Okay, so this is the table. Okay, this is the table alpha beta, this is a string. Okay, okay, if you don't know, this one is basically if your code is too long, okay, if your code is too long, you just put dot dot dot, okay, it will automatically goes into the next line, okay, this one. So basically it means that the code is continuous. Okay, let me run this. So you already transfer this one. Okay, let me run this first, so it will clear and create this one. Okay, so use this one for creating a table. Okay, alpha beta gamma delta. Okay, so this one, make sure you be careful. Okay, okay, and then for this one, okay, and its length table, basically, and length is just measured the table length. So you can see here the table length is 8 because it's 1 multiplied by 8 cell. Okay, so next, okay, you change the table data. Okay, this one, so basically this one change the hexadecimal number into the decimal number. Okay, and save it here, and then you use for n from 1 until n, this one, the length, which is only 8. Okay, so that, okay, decimal number start from this one. Okay, you have the decimal number, okay, and minus 1. For hex, this one, this is the initial value for alpha. So basically this is code for alpha. Okay, let me show you. Okay, you can see here alpha is 3b1 in hexadecimal number. Okay, so 3b1, and then beta, gamma, zeta, eta, and theta. Okay, so basically it's just add 1 by 1. Okay, it's just save in the decimal number. Okay, power of base 10 and hexa number. Okay, and then you save it in the second row. Okay, so you save this in the second row of the table. So what happened is that okay, I put it here, the breakpoint. Okay, so you can see here the GL table is now same as okay, so same as this one. Basically the first one is just creating this one. Alpha is 3b1, beta is 3b2, gamma is 3b3, something like this. That's it. That is for this one. So this one is just basically writing a string. Okay, so if you want to use string, write string, make sure you use this one, not a square bracket. I think this is called curly bracket. Okay, and lastly this one. Okay, you save the table. Okay, save the table. Okay, and then you only save the GL table, not all. Okay, and make sure there is no space for data saving. Okay, so that is the first one. Now for the second one is to load back and determine. Okay, create a function that load the data back. Okay, and determine the code for the beta. Okay, for the symbol. Okay, so I will show you this. So you can see here I put in the desktop this one, Greek hexadecimal, and make sure you change this. I already show you how to change this. Open this one, select desktop for example. Okay, and put it. Doesn't matter as long as you save it not inside the C. Okay, so this one already complete. You just close it. Okay, you already complete the hexa table. Okay, you already save it. Now you have to create a function here. Okay, so this is the function. I just copy this. Okay, but this is a good practice how to make a program. Okay, so new script. Okay, paste it, and of course you have to save it and save it with the same number as name as the function here. Okay, so save it. It will create a function file here. Recall back your chapter 5. Okay, and then you cannot run this. Okay, because this is a function, so you have to call the function. So first, close this first. And how to call the function? Of course you have to know the name of the function. So press here. Okay, so this one. Okay, for example you want to find alpha, ALPHA. Okay, so the Greek letter is 3b1. So basically this one is just how to you create a database. Okay, create a database and then load the database back. Okay, so you load the table and then this one the length. Okay, of course when you don't want to use for, you need to know the length of the data. So you can see here the current table, this one, basically check the table row 1. Okay, recall back. Okay, this one, this is the row 1, which is the name, and you compare the value with this LGL name. Okay, if the same, okay, you break. Okay, you copy the second row, this one, and then you break from the loop. Okay, remember break and continuous, chapter 4. So automatically it will show the this one glx. Okay, glx equals to this one. Okay, this one is the output. So basically it's just copy the beta hexa value. Okay, so maybe you can try understand this. This is basically the combination of all your knowledge from chapter 1 until chapter 5 and chapter 6 also. Okay, so you have function, you have for, you have if. Okay, you have load, you have save, you have function. Okay, I already mentioned that. Okay, maybe this one is a new one, length. Okay, length is just basically measured the length of the data. Okay, so maybe you can try how the length is work. Okay, this one I think special case for hexa to decimal, basically conversion from hexa to decimal number. Okay, So what else? Okay, that's it. Other file format, for other than binary and ASCII format, there is many file format you can use, but for example, spreadsheet, audio, image, okay, XML, okay, this one I think is website, okay. So all of these is will not be covered except the spreadsheet. I will show you how to do the spreadsheet later. Okay, this one you can explore on your own. Okay, you also can create a video using MATLAB. Okay, so this is load and save. Okay, so already complete how to save and load the data in the form of mat file or .dat file. Okay, now we move on to the spreadsheet. So for those who don't know what is spreadsheet, is basically Excel, this one. Okay, I think most of you know what is Excel. So this is Excel. Okay, for those who never open it, it's just basically a table that you can insert the data. Okay, this one you can put 1, 2, 3, 4, something like this. Okay, you also can write name, AA, PB, C, CC, NN, something like that. Okay, and also you can use formula. So basically you can see here, okay, this one plus 9. Okay, enter, you get 10. So if I like this, basically it will automatically add, okay, automatically update it. So basically this is the Excel. So it is quite useful because most of your database is actually saved in the Excel form. Okay, so how to import and export data? Okay, before this you can use save and load. Okay, for Excel you can use xlsread and xlswrite. Okay, so you need to memorize this. You have to open bracket. Before this you don't need to open bracket. Okay, you just write it out. Okay, but for this case you have to open bracket. You have to put the file name as well as the extension. Okay, for reading, okay, you have to put the sheet and the range. So what is the range? This one. For example, I want to copy the data from B2, so B2 until C8. Okay, so you have to write it B2 double dot, for example this B2 double dot C8, so C8. So that is how you import the data range. Okay, this is data range, this is sheet, this one is the sheet number 1. Okay, sorry, sheet number 1, sheet number 2, sheet number 3. Okay, even though I write this 2 1, this one is considered as sheet number 1, this one is considered sheet number 2. Okay, so it's not the name, it's the position, so be careful. So for the write, xlswrite, it's almost the same, but after the file name you have to put the variable that you want to export. Okay, that's it. Okay, this one is basically what I have explained before. So this is an example. Sorry I don't have this, maybe you can create on your own. Okay, so temperature reading is degree, this one. Okay, so maybe I should create the data here. So maybe I should select all and clear. Okay, so you have time, okay, Celsius and Fahrenheit, I think. Okay, so this one is 8 AM. So this one is 8 double dot 10. Okay, so highlight 2 and you can create a step here, 50. Okay, something like this. Okay, so this one maybe you can put 23. Okay, 24, 25, 24, 26, 28. Okay, so Fahrenheit, I don't know how to convert this. Okay, just leave it there and make sure you save the file, of course, because you want to import it. Okay, and make sure you use the same location as your simulation file. Okay, so I just call it AAAA. Okay, so save. So you can see here at my desktop I have the AAAA file. Okay, so you already created it. Okay, the Fahrenheit you don't know. Okay, so how to do this? Basically, okay, I open back this. Okay, I use the same file. Okay, I copy this. Okay, run this. Okay, so this one I call it AAAA, right? And don't forget the extension. If you don't put the extension, it cannot run. Okay, so okay, so you can see here, so it will xlsread, okay, the data from B2 until Z2. Okay, I think Z2 is not available, until G2 only. So this one changed to G. Okay, I run this again. Okay, and I think this one is not Fahrenheit, this one is Kelvin. Okay, so maybe this one changed to Kelvin. Okay, so Kelvin. Okay, so basically this one is what you have learned before to print. Okay, so you just tag the number up. Okay, and then xwrite, this one you have to change it to AAA. If not, you cannot save the data. So before this I don't have the Kelvin value, right? Okay, but now, so you can see here G. Okay, so originally no data. Okay, and then I run this. Okay, oh, I have to close it first. Okay, so I run this. Okay, and I open back this one. Okay, you can see here automatically it will save the data. So that is how you interact from Excel to MATLAB, and then MATLAB to Excel back. Okay, so make sure you practice on how to xlx load, read, and xlswrite. Okay, it is quite a useful thing. Okay, especially if you have a project. Okay, so you can use the data from Excel, okay, which is normally the data is saved, and then you have to use the algorithm inside the MATLAB, which is easier to develop in the MATLAB, and then you can save it back to the Excel database. Okay, so you can practice this, create your own data. Okay, so this one is circuit analysis. I think this one is quite difficult because you have to recall back how to do mesh analysis. Okay, and maybe you can try understand it on your own. Okay, so okay, maybe I will show you after this. Okay, it's already 5:50, sorry. Okay, I will continue again later. Okay, for the circuit analysis, I suggest you can try to understand it, but you have to do the mesh circuit analysis, which is actually out of our syllabus. So if you want, you can try to analyze, recall back your mesh circuit analysis. Okay, you can see how mesh circuit analysis is implemented with the algorithm. So you can see here how to calculate it. Okay, so the function here, separate IR, this one, it will call it, and then you do this. Okay, you sum everything up. So maybe you can try to understand it. Okay, This one is considered as high level programming, okay, because it's quite complicated. So we'll show you the last part of the chapter, okay, last part of chapter 6, which is debugging. So actually debugging here, I already explained it to you before, okay. So debugging your code, a software bug is a problem that exists in the code you have written, okay. So basically there is a problem with your program, okay. You can have 3 different type of error, either a syntax error, runtime error, or logic circuit error, okay. So syntax error is simply illegal expression. Basically you write something wrong, okay. So basically this is called syntax error, okay. So syntax error, MATLAB can detect it, so no problem. If you have a syntax error, it can be easily fixed. MATLAB even suggests the solution, okay. But runtime error is a logical error. This one is quite harder to fix, okay. So basically how you can detect this, okay. Okay, this one, there is no specific way to fix it actually. And the last one is the logic error, okay. Logic error that result in the program executing completely, but the answer is incorrect. This one is the hardest, okay. Basically your logic is wrong. So you have to go back to your flowchart or list of steps or pseudocode. You have to look back, okay. You have to rethink all the logic, okay. So MATLAB includes a number of tools to do the debugging. So I already show you actually. So recall back, if I say that you put something here, okay, this one is 1 step to do debugging, okay. So if you can see here, whenever an M file is written, okay, you can see here, okay, let me open a full screen. So you can see here, okay, the error, okay, this one, okay, you can see here, this is error summary, okay. Anything when there is detect error, it will highlight it in here, the location of the error. So you can move around the code. So this is the code right now showing. So this one, this error without semicolon, basically you don't forget, you forget about semicolon. So this is not a very bad error, because sometimes you want to show the output of the code, you don't put the semicolon. Okay, but if the error is, okay, very the error is marked red, you have to fix it, okay. Without the you fix the red error, okay, you cannot run the program, okay. So you can see here syntax AOL, possibly missing something, okay. So this one you have to fix, okay. So another way to stop to run the program is by using breakpoint. So this one I already showed you before, okay. Basically you just click here. For example, you want to stop at line 19, line 9, you just click it, a red dot will appear, and when you run the code, it will stop at that point, okay. So let me, maybe I show you again, okay. I already showed you before, but I will show you again. So I give you an example here, the code before. So for example, I want to stop here. So I click run, it will stop it, okay. So you can see a green arrow here, it will stop here, and this code still not run. So that's why you don't have start till val in the workspace. So if you want to continue, just continue. Basically just it will stop at the next breakpoint. If you want to look step by step, you can press step. So it will run 1 step at a time. So it will run again 1, 1, okay. So you can see how the code works, okay. That is how you do debugging, okay. You can see the output here, okay, how it is processed in the workspace. If for example you want to run it until here before it is saved, just press at the breakpoint and continue. So it will stop before it is saved, and then if you want to save, press it. Okay. Step in and step out is basically if you want, if you have a function. So if you do debugging, basically it will not go into the function. Okay. If you have a function here outside here, okay, it call outside this code, it means that the m file function outside, so it will not goes into there. But if you press step in, it will go inside the function. Okay, so this is step in and step out. Step out is basically outside go out from the function. Okay, and you quit debugging, you just press this. It will complete debug. So I already explained this. So basically this one is an old one. Maybe you use a new one, maybe to 2021. Okay, but this one is the old one. So the new one should be something like this. New MATLAB. Okay, so that's it for this chapter, chapter 6. Okay, so for the next chapter you can learn about graphic. Okay, so basically graphic is just from the data you create, you can plot graph. Okay, so this one will be in the next session. Okay, that's it. Don't forget to slide in your attendance, and don't forget about your test 1 in this test day at 4 p.m. online. Okay, make sure you set up your invigilation process. Make sure your camera angle can be seen, can see the monitor as well as your top desk. Okay, that's it. Okay, have a good day and selamat berbuka.